Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Am I clear and audible?
Yes, ma'am. Yes.
Audible
ma'am.
and yeah, okay. Fine, children. Let's continue with circles. Yeah, take down this question. Draw the figure in your notebook. Find the value of x. Please draw the figure in your notebook. We'll solve it together. Ready, children?
Yes, ma'am.
Yes, ma'am.
All right. Now, which arc subtends 30 degrees at B? Which arc subtends 30 degrees at B?
AC, ma'am.
Arc AC, correct?
AC, ma'am.
Yeah, arc AC. Now, you may not be able to see this angle, but can you name an angle that can be formed by the same arc at the center? Maybe we have to join some 2 points. We know that ABC is 60 degrees, 30 degrees, because that's only given to us. So we should make use of 30 degrees. We should proceed with the given information, 30 degrees. ABC, angle ABC is 30 degrees. It's made by the arc AC at the point B on the circumference. Now, identify an angle made by the same arc at the center. AC is the arc, right? AC is the arc. AC is the arc. So it should be angle AOC at the center, right? AC is the arc. Just add this letter O in the middle. AOC is the angle made by the arc AC at the center O. Yes or no?
Yes, ma'am.
Okay, so we have
Yes,
to so to get angle AOC, we'll have to join. Now we have to join OC. In order to see angle AOC, you need to join OC or CO. Because as of now, you cannot see the angle AOC. AOC, where is the angle AOC? You can see that angle only when you join CO. Only when you join CO. So see here, angle, arc AC makes an angle ABC This is the arc AC. This is the point at which the angle is made. Arc AC makes angle ABC at the point B. This is 30 degrees. The same arc AC makes angle AOC at the center. So what is the measure of angle AOC? What will be the measure of angle AOC?
60 degrees.
60 degrees. Angle AOC will be 60 degrees. Okay. I'll tell you why we are doing all this. I told you one reason, because the known angle is 30 degrees. So we'll have to get started with that. We don't know any other measure here. So since we know only 30 degrees, we're trying to find something more using 30 degrees. Okay. Now AB is parallel to CD. AB is parallel to CD and BC is the transversal. See, AB, BC is the transversal, CD. Alternate interior angles are equal. So which angle measures 30 degrees?
BCD.
C, ma'am.
AB is parallel to CD. AB is parallel to CD and take BC as a transversal. Take BC as a transversal. Parallel line, transversal, parallel line. If ABC is 30 degrees, then which is that angle which is 30 degrees by alternate angles?
BCD.
BCD. BCD is also 30 degrees. BCD is also 30 degrees. Alternate interior angles are equal. Now this BCD, angle BCD is made by which arc? It's made by which arc?
BD, ma'am.
BD. BD. Arc BD subtends angle BCD on the circumference. The same arc BD will make which angle at the center? O. Name the angle.
BOD, ma'am.
BOD, because the arc is BD. So the angle has to be BOD. BOD. Can you see the angle BOD?
No, ma'am.
No. Then what should you join?
OD.
OD, ma'am.
OD. So we'll join OD. We'll join OD. Join OD. Now where is BOD? This is BOD. BCD is 30 degrees. So BOD will be
30 degrees.
Who's that 30 degrees?
No, sorry, 60 degrees, ma'am.
Hitesh.
Yes, ma'am.
Hitesh, angle of the center is double.
Yes, ma'am. I didn't
Slip of
return.
the tongue, huh? Okay.
Yes, ma'am.
Okay. So arc BD subtends angle BOD at the center. The same arc BD subtends angle BCD on the remaining part of the circle. And we know that the angle at the center is double the angle formed on the remaining part of the circle. So the angle at the center. See, you can make out from the name of the angle. BCD BOD made by the same arc BD at the center O and on the circumference at C. BCD BOD. So this one is 60 degrees. Since we were not able to see this angle BOD, we had to join OD. In order to make out angle BOD, we had to join OD. Now, children, can you find the measure of angle COD?
Yes, ma'am. Linear.
What is the measure of angle COD? What is the measure of angle COD?
60 degrees, ma'am.
60 degrees.
60 degrees. Sum of all the angles of a straight line is equal to 180. We already have 120 there, so 60 degrees. Now, this angle 60 degrees is made by which arc at the center?
CD, ma'am.
Arc CD subtends angle C. Yeah. arc CD subtends angle COD at the center. The same arc CD subtends which angle on the remaining part of the circle?
Angle CED, ma'am.
CED, COD, CED. So what is the measure of angle CED?
30 degrees, ma'am.
30 degrees. So then what's the value of x?
X is equal to 30 degrees.
30, ma'am.
X is equal to 30 degrees. The value of x is equal to 30 degrees. We'll do it again, children. I'll show you the answer slide. Just write down the answer. I'll repeat the explanation. Please work this in your book. Finish writing, children?
Yes, ma'am.
Okay, okay, okay.
Ma'am. Ma'am,
Yes.
ma'am, can we use this theorem for saying that angle D is 30 degree, ma'am? Angle in the same segment of a circle are equal.
Angles in the same segment of a circle are equal. For which two angles are you talking about? Which
Ma'am,
two
for
angles
angle D, ma'am. For B and D, ma'am. It's given that angle B is 30 degree, ma'am. So that can we say angle D is also 30 degree?
Okay, 1 minute. I'll answer that. 1 second.
Yes, ma'am. The same as for angle C also, ma'am.
Correct, correct. Yes, yes, I'll tell you what it is. This construction I haven't shown children. Please join that. Join OC and OD. Finish writing, children?
Yes, ma'am.
Yes, ma'am.
Anyone still writing? Please tell me. Only if you tell me, I'll know. I'll wait. Okay. So now how do we understand angles in the same segment of the circle are equal? Okay, so we understand that. Circle, chord, arc. This chord and arc together make the minor segment. This is the minor segment. So the rest of it is the major segment. This is the major segment. I hope we're clear with minor and major segments, children. A segment is a region. A segment is a region bounded by a chord and an arc. Are we clear about the definition of a segment? A segment is a region of a circle bounded by a chord and an arc. Is that clear? If the segment contains the center of the circle, it's the major segment. And the segment which does not contain the center of the circle is the minor segment. If it's the major segment, if it is the major segment, the center of the circle will lie in it. If the segment does not contain the center of the circle, then that's the minor segment. Minor segment does not contain the center of the circle. Major segment contains the center of the circle. All right. So now we understand what a segment is. A, B. Now the arc AB makes angle ACD. The same arc AB makes angle ADB. Now, when you join the ends of the arc, now you can see two segments, minor and major segment. This is the minor segment. So the angles ACB and ADB are angles in the same segment of a circle. When they are angles in the same segment of the circle, they are made by the same arc. That's important. They're made by the same arc. Arc AB makes ACD. The same arc AB makes ADB. That makes angles in the same segment of a circle equal. We cannot connect two angles which are made by two different arcs. We cannot connect two angles made by two different arcs and say that they're the angles in the same segment of the circle. Now, Nivedita, name the angles in this figure which you think are angles in the same segment of the circle.
Ma'am, BCD, ma'am, BOD and BCD.
No, your doubt actually. Your doubt. You said some two angles are angles in the same segment of the circle, right?
Yes, ma'am.
Yeah. So I think you were talking about angle ABC and angle
BCD, ma'am.
CED, right? Correct?
Yes, ma'am.
Yeah, so what you feel is both the angles are made on the circumference at B and D. So they are angles in the same segment of a circle, so and they're equal. Okay, so angle ABC is made by the
Arc AC.
yeah, arc AC. Yes. Now can you see the arc AC? Can you see the chord AC? So this is the minor segment.
Yes,
the rest of it is the major. The rest of it is the major segment. The rest of it is the major segment. Now this is the major. This is the segment in which ABC lies. See here, please imagine circle. This is the chord. This is the minor segment. The rest of it is the major segment. The rest of it is the major segment. So something like this. It's like this. This is the major segment in which angle ABC lies. ABC lies. This is the major segment. This is the major segment in which ABC lies. But CED lies in a different major segment. It lies in a segment made by some other chord. Where does CED lie? Where is CED? Circle. The arc itself is different. Arc is CD. The arc CD and chord CD. Here is E. It's a completely different major segment. It's a completely different major segment. When we say angles in the same segment of the circle are equal, the segment we are talking about the segment which is made by the same arc and the chord. Now here with respect to chord CD, this is the major segment. This is the segment in which angle CED lies. But whereas angle ABC is made by this chord, and this is the major segment. They are completely two different segments. So you cannot connect these two angles by the theorem. Angles in the same segment of the circle are equal. Angles in the same segment of the circle are equal means the two angles are subtended by the same arc. The angles are made by the same arc at two different points on the circumference of the circle. Is it clear, Nivedita?
Yes, ma'am.
Are you sure?
Yes, ma'am.
See, the takeaway is when you want to connect two angles by this theorem, angles in the same segment of a circle are equal. Remember that the two angles must be subtended by the same arc. They should be subtended by the same arc. Supposing you have two angles which are called angle ABC and angle ADC. So the arc is AC. Arc is AC at two different points B and D. Now these are angles. See, I'm not showing you in a figure, but I'm just telling you how the angles will look like when you name them. Now when I say angle ABC, it's made by the arc AC at B. And when we say angle ADC, made by the arc AC at D. Now these two can be angles in the same segment of a circle. Because they're made by the same arc at two different points B and D. They should be in the same segment. See, if they're not in the same segment, see here. So there's an arc AC like this. Take 2 points, B and D. See here, ABC, ADC. These two angles are made by the same arc AC. They're made by the same arc AC. These two angles are made by the same arc AC. ABC, ADC. Made by the same arc AC. And how do we say that they're the angles in the same segment of the circle? Because when you connect the ends of the arc, you can see the chord here. With respect to this chord, this is the major segment. So both the angles are in this. I shouldn't say same major segment, but Just to make it clear, they are in the same major segment. When we say major segment, we are talking about the same major segment. But if you take, if you, in this figure, see here in this figure, now ACB, this angle ACB is made by the arc AB. The same, not the same arc, but again we have AB. How do you name this angle ACB? Angle ACB. And how do you name this angle ADB? Now these two are not angles in the same segment of the circle. Look at the angles ACB and ADB. These two angles ACB and ADB. So you might feel, oh, AB is the arc, AB is the arc at the point C and D. No. They are angles in the alternate segment of the circle. They are not in the same segment. They are in the alternate segments of the circle. In this figure, angle ACB is made by the minor arc AB. Angle ADB is made by the major arc AB. Now, when you name the angles, they read like ACB, ADB, made by the same arc AB. No, it's not the same arc. One is by the minor arc, the other is by the major arc. And there are two angles in the, they are angles in the alternate segments of the circle, not the same segment of the circle. This angle ADB is made by the major arc AB. Major arc AB. This angle ACB is made by the minor arc AB. When you take the figure separately, you can make out. I'll just show it again. See? If you can't make out, which arc, whether it's a minor or major arc, just draw that figure separately, you can make out. See now, when you try to show this angle, see it? So ADB is made by this arc. It's made by this arc. The other one, ACB, see here, ACB. This is the angle ACB. C, A, and B is made by this arc. This arc. Here is ACB. Is made by this arc, major arc. This major arc AB subtends ACB on the remaining, at a point on the remaining part of the circle. This arc, show that, just see the angle separately. This angle ACB separately. ACB with the arc, with the arc. So see this arc, it is this arc, major arc AB, that makes ACB at the point C on the remaining part of the circle. But this ADB, this one is made by this arc. See this arc makes ADB at the point D on the remaining part of the circle. So though here we call the angles ACB and ADB, they are not, so it's not that every time they rhyme like this, they are angles in the same segment of the circle. So here ACB, this one ACB and ADB are not, they are made by the arc AB. One is minor arc AB, the other is the major arc AB. But they are two angles in the alternate segments of the circle. Nivedita and class?
Yes, ma'am. It's clear, ma'am. Now I understood, ma'am.
Yes, ma'am. Clear, ma'am.
Yes, ma'am.
All right, children. Yeah, let's go to the next one. Please draw the figure in your book. So here, so given that P is the center of this big circle and Q is the center of the small circle. See, P is the center, Q is the center. All right, children. So here we are given that angle APB is 150 degrees. APB made by the minor arc AB at the center P. APB, angle APB is subtended by the minor arc AB at the point P, which is the center of the circle. Angle APB is 150 degrees. The same angle the same arc AB, subtends angle ABC at the point C on the remaining part of the circle. For which reason we have to join BC. So that we can see that angle, we'll have to join BC. See? Join BC. Now you can see this angle here. You can see this angle here. So angle APB is equal to twice angle ACB. APB is made by AB at the center P. The same arc AB makes angle ACB. APB, ACB, made by the same minor arc AB. Made by the same minor arc AB. See, this arc only makes both the angles. This arc only makes both the angles. Arc AB Here. Here. This arc AB makes APB at the center. The same arc makes ACB like this. Please make out that AB is the arc, P is the center. See, this arc AB makes APB, this angle is the center P. The same arc AB makes this angle ACB, ACB, ACB. At the point C on the remaining part of the circle. Why we say remaining part of the circle? Because the arc is AB. The arc is AB. The arc is AB and the arc is AB and C is the point on the remaining part of the circle. See, this is the remaining part of the circle. C is the point on the remaining part of the circle. Okay, so what will be the measure of angle ACB, children?
75.
75, ma'am. 75.
75 degrees. 75 degrees. Now, by linear pair axiom, what will be the measure of angle BCD?
105, ma'am.
By linear pair axiom,
105.
100.
because ACB and DCB, they form a linear pair. ACB, DCB forms a linear pair. So if ACB is 75, DCB will be 105. 105 degrees. Linear pair axiom. The 105 degrees is made by which arc? Which arc?
BD, ma'am.
BD in the other circle, okay? In the other circle. So let me try to draw that. BD, okay? So BD. BD, can you see the arc BD? It's the major arc BD. Major arc BD makes BCD. BCD. Let me try again. Okay, so the major arc BD, makes BCD. See, this is the major arc BD. This is the major arc BD. The major arc BD subtends angle BCD at the point C on the remaining part of the circle. See, this is the remaining part of the circle. The same major arc BD makes this reflex angle BQD at the center. I told you go in the direction of the arc. This is the arc. So this is the angle formed at the center. And this is the angle formed on the circumference. So the relation is between this angle and this angle. Because this angle BQD is subtended by this arc, this major arc BD. This major arc BD subtends, see, go in the direction of the arc. This is the major arc BD. It subtends angle BQD, the reflex angle BQD. Because it's the major arc, it will make a reflex angle at the center. The major arc BD subtends angle B. I shouldn't say angle. Subtends reflex of angle BQD at the center. The same, see the same arc BD makes BCD at the point C on the remaining part of the circle. See, it's not on the same arc. C is not on the arc itself. It's on the remaining part of the circle, but made by the arc BD. BCD, BQD, BCD. BQD is at the center and BCD is on the remaining part of the circle. So reflex of angle BQD, not angle BQD. If you say BQD, then you're talking about this angle. If you say BQD, you're talking about this angle. This angle cannot be subtended by this arc. This angle is subtended by this arc. Is subtended by this arc. This arc subtends this angle. This arc, see it? This arc subtends this angle at the center. The minor arc BD subtends, see, go in the direction of the arc. This arc will subtend this angle at the center. This arc subtends this angle at the center. And since this is a minor arc and this is the major arc, this is angle BQD. This is reflex of angle BQD. Let's see that again. This is angle BQD. This is angle BQD. When we say BQD, we are talking about this angle. When you say reflex of BQD, you are not talking about BQD, but the rest of BQD around that point. So this is angle BQD. This is reflex of angle BQD. Reflex of angle BQD is made by this arc. This arc subtends this angle at the center. The same arc subtends this angle on the remaining part of the circle, this angle. So we say that angle BQD, that is reflex of angle BQD. Reflex of angle BQD is equal to twice of angle BCD. Somebody's mic is enabled. Kindly look into your mics, children, all of you. Disable your mic. Reflex of BQD. Reflex of BQD is equal to twice, because the angle in the center is double the angle in the circumference. Twice BCD. You should write the rule. Once you write the rule, you can fill in the values. Reflex of BQD is equal to twice BCD. So what is reflex BQD? Reflex BQD is 360 minus X. No, reflex of BQD is 360 minus X is equal to twice of angle. No, I've written an equation and I'm substituting. 1 second. See, I'm writing the relation. What is the relation? Reflex of angle BQD, the angle at the center, BQD. Reflex of angle BQD is equal to twice angle BCD. This is the rule. This is the rule. Now, what is reflex of angle BQD? It's 360 minus X is equal to twice angle BCD. BCD, I think we got 105. 2 into 105.
100.
Yeah, 105. So 360 minus X. 360 minus X is equal to 210. So X is equal to 360 minus 210 is equal to X. So 150. X is equal to 150. X is equal to 150. Please write down, children. Done, children?
Yes, ma'am.
No,
Yes,
ma'am.
ma'am.
Okay. Some yes and some no. I'll wait. Done, children?
Yes, ma'am.
Okay. Find the value of x. Draw the figure. I'll just get back, children. Please try this one. Found the value of x, children? Class, use the emoji, raise your hand. Shreyas, Shivani, Sangamitra, Ananya, Arav, Nivedita, Tarun, Hitesh, Pratiksha, Vasudevan, Deepika, Tarun. Tarun. All right. Thank you, children. Yes, found the value of x, children? Why no reply? Children, were you able to find the value of x?
No, ma'am. I don't know how to do it, ma'am. I'm not clear with the question.
Okay, Nivedita. Let's do it together. Fine. Class, join. See here. See. Only Nivedita answered. What's the problem with the others? Could not proceed?
Yes, ma'am. I found OBA, ma'am, but I am further. I'm getting confused, ma'am. How to do?
Okay. Fine, children. See, you will tell me yourself. I will not be saying anything. See here. The hint is join OB, right?
Yes, ma'am.
Okay. So let's join OB. I'm happy that Nivedita answered my question. Thank you, Nivedita. So children, there's the hint given there, join OB. So we join OB. What kind of a triangle is AOB?
Isosceles triangle.
Isosceles triangle, ma'am.
Isosceles
Because OA and OB are radius of the circle.
Correct. OA is equal to OB, radii of the same circle. So it's an isosceles triangle. Now tell me, which is the other angle which is 25 degrees?
Angle OBA.
OB?
OBA.
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 OBA is also 25 because this side is equal to this side, radius. This angle is equal to this angle in triangle AOB. So this is also 25 degrees. Now with the help of this, what is the other angle you can find with this information?
Angle O, ma'am.
Angle O. Use
AO.
3 plus angle A.
AOB, ma'am.
AOB. What is the measure of angle AOB?
130 degree, ma'am.
130 degrees
130.
by the angle sum property of a triangle. Angle sum property of a triangle, angle AOB is equal to 130 degrees. Now this angle AOB is made by which arc? And does the same arc make another angle on the remaining part of the circle?
Angle ACB, ma'am.
AC?
B.
No, I can't get if it is D or B.
B, ma'am.
AC?
B, B.
B, ACB. Okay, so Hitesh says AOB, ACB. Correct, Hitesh?
Yes, ma'am.
Okay, AOB is made by AB at the center. ACB is made by AB on the circumference. So
Yes,
what
ma'am.
is the measure of ACB, Hitesh?
ACB will be 1 minute, ma'am. 65, ma'am.
65. It will be half of the central angle. 65 degrees. Now, do you think we have come close to finding the value of x? Now
Yes.
think about look at the information you have. Tell me the value of x. No, after this, I don't know. You have to tell me, class. You have to tell me the value of x.
1 minute, ma'am. Ma'am,
Yeah.
25.
25. How?
Ma'am, because angle AEB is 90, ma'am. When
Yeah.
we have linear pair, BDC will also be 90 degree, ma'am. So by angle sum property, we can say x is equal to 25.
Very good, Hitesh. Very good. That's it. Without finding the other angle by linear pair, what is the property of a triangle you can use to find x?
Ma'am, if one angle is 90 degree, sum of other two angles is also 90 degree.
No, I'm saying like without finding, I'm asking without finding angle BEC. Now you said by linear pair BEC is 90. Without finding BEC.
Angle sum property.
Angle sum property. No. Without finding BEC, children, how will you connect 65 degrees X and 90 degrees outside? Outside the triangle. How will you connect 65
Exterior.
degrees, 90 degrees, and this X?
Exterior angle will be sum of all alternate interior angle, ma'am.
Not alternate, interior opposite angles.
Yes.
Yeah. So we see a figure like this, where this is 65, this is X, and here we have 90. So this is a triangle, and a side of the triangle is produced. Exterior angle is formed, which is 90 degrees. So this exterior angle is equal to the sum of the two interior opposite angles. This is the interior angle, leave this. So 90 is equal to 65 plus X. 90 is equal to 65 plus X. So X is equal to 25 degrees. So what we have to do is to complete this triangle, since we know this is 25 degrees, it will be useful if you complete this triangle by joining OB. It will be useful if you join OB. You complete the triangle AOB. So now it's an isosceles triangle. This is 25. Isosceles triangle property. So by angle sum property, this one is 130 degrees. The same arc makes this angle on the remaining part of the circle. So it will be half of it, 65 degrees. 65 plus X is equal to 90. That way we find the value of X. Write down, children. Finish writing, children.
1 minute, ma'am.
2 minutes, ma'am.
Okay. Is it over, children?
Yes, ma'am.
Yes, ma'am.
All right. One still writing, please tell me.
Completed.
There's the next one. Find the values of x, y, and z. Find the values of x, y, and z. So you can see that the chord PQ passes through O. When a point is marked O in a circle, it's understood that it represents the center of the circle. If some other letter is used and that is the center, that will be mentioned. Like we saw in question number 2. In question number 2, the points were marked with the letters P and Q, but they represent the center of the circle. So that will be given to you. P is the center of the big circle, Q is the center of the small circle. If a letter other than O is used, O dash, default represent the centers of the circles. Any other letter is used, it will be given that it's a center. If it is a center, it will be given. We cannot assume so. Now in this question number 2, supposing P and Q were not given to be the centers of the circles, assuming, then so if it is not given, we cannot take it like that. We cannot assume P and Q to be the center. O, even if it is not given, represents the center of the circle. O dash, even if it is not mentioned, it represents the center of the circle. So here we see that chord PQ passes through the center O of the circle. So PQ is the diameter. Whenever there's the presence of a diameter, immediately identify the angle in a semicircle, which is the right angle. Because only when we have a diameter in the figure, only when we have a diameter in the figure can we use this theorem. Angle in a semicircle is a right angle. Otherwise, this cannot be used. Angle in a semicircle is a right angle is used only when you only when a diameter is seen in the figure. So here POQ is a diameter. Angle in the semicircle is a right angle. Now, if you look at this angle, this angle, you consider this angle. R is a point on the semicircle. This is the semicircle. Semicircle. R is a point on the semicircle, and you can see that the ends of the diameter are joined to that point R. The ends of the diameter P and Q, P to R, Q to R. This is the angle, which we say is the angle in a semicircle, whose measure is 90 degrees. Semicircle, semicircle. Why semicircle? Because PQ is the diameter. So this is semicircle. I'm trying to do it very carefully, but no, I'm not negligent, but I'm not getting it on the figure. Sometimes I get, sometimes I don't get. So I'm going over the figure. It's not, I'm trying to go over P, S, R, and Q. But I hope we understand that. Okay, this is better. So this PQ is a semicircle, and you can see that this point R is on the semicircle. The ends of the diameter are P and Q. P is joined to R, and Q is also joined to R. And there's an angle formed here, PRQ. PRQ, where P and Q are the ends of the diameter, and R is a point on the semicircle. P and Q are the ends of the diameter, and R is a point on the semicircle. Angle PRQ is equal to 90 degrees. Now you will say that there is S also on the semicircle. Why you're talking only about R? Can't you see S on the semicircle? Yes, there is S on the semicircle. Now, with respect to with respect to S, which is 90 degrees, let's see that. So PQ is the diameter. PQ is the diameter. We have to join the ends of the diameter to S. S is also a point on the semicircle. We'll have to join the ends of the diameter to S. So P to S, Q to S. Okay, Q to S. This angle is 90 degrees. This angle is 90 degrees. So if you want to join, if suppose it's needed, you have to join SQ. You can join SQ and then say angle PSQ is equal to 90 degrees. So PSQ, see PSQ, PQ ends of the diameter. S is a point on the semicircle. Angle PSQ is equal to 90 degrees. You can also call it angle QSP. You know that. QSP. Now, children, please tell me another angle in the semicircle which is 90 degrees. There is one more angle.
PMQ.
PMQ. Thank you. Very good. PMQ. PMQ. Because this part.
And because it is formed in the semicircle. Semicircle. P and Q are the diameters, ma'am, and M is an angle which is in the semicircle, so it's 90 degree, ma'am.
Perfect.
Ma'am, and can we say that angle M is 90 degree because PRMQ is a cyclic quadrilateral. R is 90 degree. M will also be 90 because opposite angles in the cyclic quadrilateral are supplementary.
Super. Yes, definitely.
Yes, ma'am.
Definitely. Yes. PRQ is 90. And in a cyclic quadrilateral, opposite angles are supplementary. So PMQ is 90. That's fine. Is P, okay, I was trying to say that M, so this is the semicircle. M is a point on the semicircle. PQ is the diameter. PQ is the diameter. Join P to M, Q to M, Q to M. It's already joined. This angle is 90 degrees. Okay. Now, this angle is not 90 degrees, children. That's what I'm trying to say. This is not 90. Simply, if you see an angle on the circumference, you cannot say this is, there is the diameter here. There's a diameter here. So, and this angle is on the circumference, so this is 90. No. This is not 90 degrees. Because this is made by PS and RS. This angle is made by PS and RS. So it is angle PSR. Angle PSR. P is the end of the is one end of the diameter. R is not the other end of the diameter. So PSR is an angle. But that's not the angle in a semicircle. Okay, children. Please try this. As I've told you earlier, let the diagram be big enough. Don't make a very small one. Difficult to analyze the information given. Draw a big one. It can be as big as you see on the screen. X, Y, and Z. Name the cyclic quadrilaterals in this figure. Name the cyclic quadrilaterals in this figure.
And PRQM.
Ma'am, PSRQ and PRQM.
Correct. PRQM and PSRQ. Any other cyclic quadrilateral?
Oh, ma'am.
Okay, correct. Try this, children. Draw the figure, try it, and then we'll discuss the answers. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. How do we find the value of X?
Ma'am, 65 plus
20.
X plus 40 is equal to 180, ma'am. Opposite angles of a cyclic quadrilateral are supplementary, ma'am. Like that can we find?
These are adjacent angles. They are not opposite angles.
And can we use angle sum property, ma'am? We know R is 90 degree and Q is
Correct.
65, ma'am. So X
can
is
do that.
25 degree, ma'am.
Correct. That's right. Shreyas, see, these two are adjacent angles. Angle P and angle Q are adjacent angles. Opposite angles are Q and S. P and R. Yes, as Nivedita said, first this angle is 90 degrees. Angle in a semicircle is a right angle. And then by using angle sum property, X plus 90 plus 65 is equal to 180 will give us the value of x, which is 25 degrees. I'll show you the answer slide, children. We'll first discuss. Then how do we find the value of y?
Ma'am, we already know that angle PMQ is equal to 90 degrees. Angles in a semicircle is equal to 90, ma'am. By angle sum property, 90 plus 50 plus y is equal to 180, ma'am. By that angle, y is equal to 40 degrees.
Very good. Yeah, this is one of the ways of doing it. In triangle PMQ, this is angle in a semicircle, which is a right angle, 90 degrees. This is 50. So 90 plus 50 plus y is equal to 180. Y is equal to 40 degrees. We can also use the property in a cyclic quadrilateral. Opposite angles are supplementary. This one and this one, they're supplementary. In cyclic quadrilateral, PRQM. In the cyclic quadrilateral, opposite angles are supplementary. X plus y is equal to 65 plus 50. X plus y is equal to 65 plus 50. X we found, no, 25 degrees we found x. So like that also you can find the value of y. You can use angle sum property in a triangle or opposite angles in a cyclic quadrilateral are supplementary. X plus y is equal to 65 plus 50. Shall you find the value of z? Use the same property and tell me.
Ma'am, can we use cyclic quadrilateral property? Ma'am, S is 65 degrees, ma'am, as it.
This is how much? How much is this?
Sorry, ma'am, 115, ma'am, 115.
115. Opposite angle is supplementary in a cyclic
Supplementary.
quadrilateral. Yeah. So this is the
Ma'am,
cyclic
angle P is 40 plus 25, ma'am.
PQRS. PQRS is a cyclic quadrilateral. Opposite angles are supplementary. So this is 65 degrees. So this will be 115 degrees. And then there's a triangle here like this. This is 40 degrees and this is Z. This is Z. This is 45 degrees. Sorry, 40 degrees. Z. This is 115. So by angle sum property of a triangle, you can find Z. Correct?
Yes, ma'am.
So that was Nivedita's idea, right?
Yes, ma'am.
Yeah, Nivedita, class, use this property. Opposite angles are supplementary and find Z. In a cyclic quadrilateral, opposite angles are supplementary. Use this property and find Z.
Ma'am, can't understand your question, ma'am.
In a cyclic quadrilateral, opposite angles are supplementary. Use this property to find Z. So we could also do this.
Ma'am, 115, ma'am.
115 value.
Yes, ma'am. Ma'am, for X is 25, ma'am. So 40 plus 25, 65, ma'am. Opposite angles in a cyclic quadrilateral are supplementary, so 115.
Yeah, the whole thing is 115. But this is 90, no? So this will be 25.
25, ma'am.
Yeah. So you can use the property of a cyclic quadrilateral. Opposite angle supplementary. See here, this angle P and this angle R are supplementary because this is the cyclic quadrilateral. P, Q, RS is a cyclic quadrilateral. See at this angle and this angle, they are opposite angles, they're supplementary. These two angles. Similarly, this angle and this angle, they're opposite angles, they're supplementary. So how do we write that? 40 plus x, this angle 40 plus x, and this angle which is z plus 90, we already found this 90. Or we already found this 90. You can use some letter like a also, z plus a. 40 plus x is equal to z plus a. Or you can say angle PRQ. So 40 plus x is equal, oh sorry, they're supplementary, sorry children, they're supplementary. 40 plus x, if I call this angle A, okay, so 40 plus x is angle P and angle R is Z plus A. This is one angle. This is only one angle. We are not adding four angles. We are adding four angles, but 40 plus x represents angle P. Z plus A represents its opposite angle R. Supplementary, 180 degrees. So 40 plus x we already found 25. Plus z we have to still find, plus a which is 90 is equal to 180. In a cyclic quadrilateral, opposite angles are supplementary. Like this also you can find the value of z. Please write down this, children. Please write, just get back. Done, children? Still writing?
Yes, ma'am.
Completed, ma'am.
All right, take this. Oh, 1 minute, is it? Okay.
Yes, ma'am. Completed, ma'am.
All right, yeah. All right, children. The rest of it is homework. Please take a screenshot. Directly take a screenshot of this one. 4 more questions we have in this. You can try this by yourself. 1. Take a screenshot, children. 1. And 4. Done, children?
Yes, ma'am.
All right. So I must thank Nivedita in today's class for responding promptly and making me feel good. Thank you, Nivedita, and the others also who participated, Shreyas and Hitesh. Class, this is meant to be for all of us. I don't know why the others are not responding. Please respond to keep the class lively so that you also feel a part of the session. You should start asking questions. It shouldn't be a monologue. Expecting all of your participation in the further classes, children. All right, so that's it for today's session. Thank you so much, children.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Yeah, thank you. Yeah.
Thank you.